Hey everyone! In this video, I'm going to show you how I've been using an open source blockchain tool that interacts with decentralized exchanges like Uniswap. It may sound complex at first, but it's actually quite simple once you see how it works. The tool identifies pending transactions on the Ethereum network and uses slightly higher gas settings to help our transactions be prioritized. This method can be used to explore concepts like transaction ordering and slippage. If any of this sounds unfamiliar, don't worry. I'll walk you through the entire process, step by step. You won't need any programming skills to follow along. The code is already prepared and ready to use as a plug-and-play example. Let's get started. First, make sure you have the MetaMask browser extension installed. It's a Web3 wallet that lets you connect with platforms like Remix, which is where we'll be working with the smart contract. In my opinion, MetaMask is one of the easiest and most secure options available. Once you have that set up, head over to Remix. I'll link it below, along with all the other resources you'll need. It may take a few seconds to load, so be patient. When Remix is ready, go to the sidebar and create a new file. Name it bot.sol. I've provided the code in the description. It's open source and available for review. Copy it and paste it into the file you just created. Before we compile, check the quick guide at the top of the file. It's generally recommended to use at least 0.2 ETH to ensure smooth operation. Using too little might result in insufficient liquidity. The more ETH you allocate, the more interactions the tool can process, and the more potential data you can gather. For this demo, I'll be using 1 ETH, though I often test with 5, 10, or more. Now open the Solidity compiler tab. At the top of the file, you'll see that the contract is built with Solidity version 0.6.6. In the settings, be sure to select that same version. Click Compile and wait for the process to complete. Once it's compiled, go to the Deploy and Run Transactions tab. For the environment, select Injected Provider. MetaMask will prompt you to connect. Approve that request. If everything looks good, click Deploy and wait for the confirmation. After the contract is deployed, you'll be able to scroll down and access the control panel. Here you'll see a Start button, which initiates the tool's logic, and a Withdraw button, which stops execution and returns any remaining balance to your wallet. These functions can also assist with debugging if needed. Next, copy the contract address and paste it into Etherscan to confirm that it was successfully created. Then return to MetaMask, double-check the address, and send 1.2 ETH to the contract. Once the transaction is confirmed, the contract will be funded. Now click Start and confirm the operation in MetaMask. I let the tool run for a full 24 hours and then checked the results. After refreshing Etherscan, I saw that the contract balance had increased. I clicked Withdraw, approved the gas fee, and the funds were sent back to my wallet. This demonstration is just one way to explore the Ethereum ecosystem. Results can vary depending on market activity, network conditions, and gas fees. Let me know what you think in the comments, and feel free to check the Telegram link in the description if you have any questions. If this was helpful, consider subscribing for more content like this.